we had a general introduction to Excel last week, so we're going to keep that going, and we're going to now play with Excel tonight. So the first thing I want to say is, anytime we get a data set that you've made or somebody else has made or whomever made it, we always want to make sure it's golden, right? And if we have crud going in, the best we could possibly hope for is crud coming out. So what we're going to do in today's session is pretty much just spend some time talking about how we can get our arms around this data set, right? How we can kind of hug this data set, we can see what it looks like, we can see what it feels like, we can see the ups and downs, and then make sure it's ready to be used. And all that stuff is before we even get to the serious graphing, right? So we want to just make sure that everything is not garbage to start with. And this is a non-trivial thing. So this data set that we're going to give you today is relatively straightforward. It's from an international curated database, so it doesn't have that. It's probably been pretty checked out. But in most cases, that will not be the case. Most of the data you're going to find off some government website, some nonprofits this, some whatever. Maybe it's good, maybe it's not good. And so you always need to go through this process anytime, even if you create the data, because maybe you accidentally made some errors, but particularly when it's not your own data. So we first want to make sure there's no garbage in, garbage out, and then we're going to do not that much graphing today, right? We're just going to be spending a lot of time just learning how to get ready to graph. And so this is this whole, we're going to crawl before we're going to walk, and we're going to walk before we run. And I know some people want to just run right now, but we want to make sure we're going through all these paces so that in the future, we always are not running too fast when we get a data set. Okay.
Don't want to pull a hamstring.
Don't pull a hamstring. It would be the worst thing in the world if Patrick Mahomes were to get a hamstring pulled this weekend. Not. Just saying. Okay. So no opinions there. So okay. So this is going to be our approach for when we get a data set that we didn't make, right? So essentially this will be the same approach even when it's ours, but when it's ours, we can maybe skip some of these things because we probably know what the variables are if it was, from our own study. So this is sort of the most broadest thing. So we don't know maybe entirely where this data set came from, don't know if it's been curated yet, so this is going to be the general approach. So I'm going to run through each of these steps in a second, but the basic approach is we're going to orient ourselves to the data, we're going to take a quick glance at the data, we're going to do a quick and dirty kind of just, maybe it kind of looks like this type of relationship, and then maybe look for some patterns. Throughout the whole thing, I have it off to the side here because it's really not a step-by-step. This pre-processing is something that'll happen throughout. So it's not as if it's one step and you go on. A lot of times, especially if it's a big data set, especially if it's a complex data set, we don't always catch all the errors or catch all the formatting changes that we might need to make to the data until we actually start to get into it. So there's kind of this feedback loop here of kind of constantly maybe going back and tweaking, cleaning, adjusting, and that's just sort of a nature of the beast. And then only after we've done all of that stuff do we finally get to, okay, now let's actually make our first real visualization. And the thing I want to mention about this is Professor Spies and I might talk about a draft, okay? Now, with the exception of this little level 3 here, which says quick and dirty, by draft, when we say draft, you hear something different than what Professor and Spies and I mean by it. So I want to be very clear. So when we say draft about anything, we mean a complete draft. So we say, hey, take a stab at making a figure, right? Make your draft figure for this week, and then we're going to have a revised version due next week, whatever. That does not mean a sort of gimped out, random, scrappy, ugly thing, right? We want it to be good and properly labeled, easy, fonts large enough to read, all that kind of stuff. And then, of course, as we've mentioned, we can always make these things better and tighter and tighter and tighter. But we don't want you guys turning in a half-baked, rando thing, oh, my draft. No. Everything is always, fully looked at and all this. Understanding that you can make it better, but draft doesn't mean half done. Is that? Yep, cool. Okay, so let's look at these things. So this is the data set that we're going to look at in a second. This is the one that you've already seen, you've already played a little bit around with. But let's talk about the different conceptual approaches we're going to take this. So I get a data set. And the first thing we want to do is orient ourselves to this data set. What's going on here? Okay, so what are these variables? So in this case, there's a bunch of variables across the top row. And some of them are pretty obvious, like disaster type. Okay, I pretty much know what that is. But others are less so, right? So there's this a thing that says total damage and then parentheses and a dash and 3 zeros in the US and a dollar sign. There's a thing called CPI. And so very often there will be things there that you aren't sure what they are, or you're totally unsure what they are, or what have you. So you're going to want to, before you get into the data set, you're going to want to know what that is. So you're going to want to know what that variable was trying to measure. You're going to want to know what the units that, is that square meters, is that hectares, is that acres, all that kind of stuff before we even start to touch anything. And that could be in a couple different places. That could be in another tab in the data sheet. That could be on the website that it came from. That could be in the paper that you sourced it. So there's multiple possible places for it. But regardless, you want to make sure you understand what those things are first. Next, we want to start to get a sense of the shape of the data, kind of like the big picture, what it looks like, right? And so that would be things like our summary stats. What's the biggest number? What's the smallest number? What's the average? What's the variance? That type of stuff. So we say, okay, so this number ranges from X to Y. Most of the values are kind of clustered around here, that type of thing. And so, for example, in this case, I was looking at the total number of folks that died. In this case, this is from wildfires from our data set in 1911. And so, okay, so I'm already starting to get a sense. Okay, so some years it's in the 40-ish ranges. Some years it's nobody. Some years it's in the thousands. Okay, so I'm starting to get a sense of that. So that's sort of the basic data overview. And then next is a great project. Okay, so now I know the variables. Now I have a sense of the range of the order of magnitude of the values, etc. Next, I want to just sort of think to myself, okay, so what do I want to do? And again, this is really important. These things are so tempting when we have these drop-down menus to just barf out some random figure, and I can't tell you how many times a student will generate a figure that doesn't make any sense, right? I'm not talking about the data in the figure. I'm talking about why would you choose that as a format to present data in for this particular data? And it's because they just sort of randomly, okay, blah, 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 blah. So give yourself half a second. And so that could either be sketching it out on paper, or it could be sketching out in your mind. But you're like, okay, I think I want to see how, on the upper right here, so maybe I want to see how when I go from the first year in the data set to the most recent year in the data set, if deaths or expenses or whatever go up. And so maybe I would have a guesstimate that it kind of does something like this. Okay, so then maybe I want to do a line chart, that kind of thing, right? Doesn't necessarily need a huge amount of time, but please do this every time. Give yourself 30 seconds, a minute or two, if not more time, to step back and what would really show this relationship that I'm trying to explore. In this case, I was curious as to whether the cost or the mortality rates changed over time, or was it the same? Was it about the same expense back in the day as now? That kind of thing. And then you can knock out a quick graph, right? So a simple, quick one from one of the pull-down menus. Not pretty. This is the one exception to where we said, don't ever. A draft is always complete. This is just sort of a quick boom. Does the data make sense, or does it give me an error? Is there something wrong with my data layout? Okay, so I got something that comes out. Okay, so my rough idea of some kind of line chart over time, if I do a quick and dirty, just kind of boink, does it come out? Yes, something comes out. Okay, so then that sort of passes my initial smell test, and now I can start to think about how to do it maybe more robustly. And then as we start to look at the data, either in tabular form or maybe that initial quick and dirty graph, maybe start to get a sense of what the pattern might be. And so in this case, here's the cost of the values in that data set, the cost of the wildfires. And it sure looks like over time, the cost is sort of low for many years. And then as we get to more recent times, it kind of gets big, right? So I kind of drew my conceptual arrow in there, that's the sort of pattern that it looks like it's happening to, right? And so we start with what we say by inspection, meaning no statistics, no hardcore, just what does it look like? It seems like it's going this way. Haven't done any statistics yet, haven't proven it that it's at the P.05, but I'm starting to get a sense. So again, before I've done any serious graphing, I've already got a sense of what my data is like, magnitudes and this and that. Got a sense if it's going up, going down, that kind of stuff. And now I can start to enter into my next more robust thing. And as we're going through here also, again, this is sort of like a Lego blocked onto the side. At any point as I'm going through step 1 to step 2 to step 3, it could be like, oh, that's weird. Or I go to make that quick and dirty graph and there's something super weird about the graph. Like, oh wait, is that right? Or is the graph correct, or is that presentation correct? Or maybe there's something messed up with my data. Maybe it was typed in wrong, maybe I skipped a year, or right? So then I'm gonna go back and check and look at the data, right? And so there's sort of 2 broad categories here, and Professor Spies might have an alternative name. Some people prefer different names. Different disciplines tend to have slightly different terminology here. But all of this stuff on the right and left, we put under this pre-processing, right? So before we're doing our formal analysis, before we're doing our full real graph, we're kind of rope-a-doping it into shape, right? We're kind of making sure everything's going to conform, everything's going to be cool and rock and roll. And I can't tell you how many times work with you guys, and it's really, when you start to get your data, you're like, oh, this is so exciting, I want to graph it, and you kind of start running ahead, and then usually we're like, okay, hold on a second, like let's get this all, totally formatted correctly. And a lot of times you're like, oh my God, dude, you're so lame, I'm really excited, let me graph this, right? And what'll tend to happen sometimes, not every time, but sometimes, is you start, and you see this graph, and you go, oh my God, this is great. Oh, and then I wonder if, maybe this is showing that, and you kind of start getting excited and start trying to follow the pattern, which is awesome, because we all love data, and data is cool, right? Yes. Oh my God, data's cool, right? Geez, you guys need more coffee in this evening class, clearly. So data's cool. And so we want you to, once we want to do all this kind of lame work, we want to clean all the dishes, want to sweep up after the dog now, so that when we're ready, we can just charge. And as you're starting to get that inspiration, hey, I wonder if X relates to Y. I don't know, ching, 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 boom. Oh, yeah, it does, okay. Hey, I wonder if Y relates to Z. Ching, 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 ching. Oh, hey, look, and we can do that mental exploration, as opposed to starting to go down the data exploration route, then all of a sudden get stuck and realize, no, that thing isn't right. Okay, now I got to go back, and I got to redo it all, right? So the best practice is to avoid it. Sometimes that happens, that'll still happen sometimes, but we want to, as much as possible, do all that cleaning before we get into the excitement mode. So when we get into the excitement mode, it's just pure playing around. It's like, hey, let me try this. What about this color? What about this line? And you can really get into that part and not be distracted by potential errors in the data. Okay, so for data wrangling, this is basically getting the data. In some cases, there's nothing wrong with the data. It's totally cool. There's nothing wrong, 100% fine. But for the type of visualization you might want to do, we might need to tweak the data somewhat, right? So again, that doesn't mean the data was entered incorrectly or is wrong, but it's maybe not in the optimal format for the particular type of analysis or visualization that we want to do. And some of that is just obvious, as we'll see in a little bit. Others are maybe a program or a particular tool specific requirement, the way you have to format the data. But either way, that would all be pre-processing. The most common examples of this will be transformation is one. Transformation sounds like cheating, right? So this is, maybe you guys remember this from stats class? Yeah. So it kind of seems like you're cheating. So I'm gonna do something to all my data and change it. And you're like, what, dude? And so for the transformation, the 2 most common ones that we encounter in the types of data sets that we deal with most frequently are arc-sine transformation and log transformation. Arc-sine are applied to proportional data, or what you might see represented as percentage data. And log transformation are applied when we have density counts of stuff. Now, these transformations are applied to all of the data. We don't apply it to like the first quadrat or the third quadrant or something. We apply it to all the data at the same time. And the reason we do that is for a couple reasons, but one basically to help us more closely approximate the assumptions of a lot of the statistical tests that we'll use to see if there's something significantly different between population A and population B. So remember we talked about that normal curve, that normal distribution? Not all data is like that. And a couple glaring examples are the proportional data. And so you might have it entered as 10% in your data sheet. We never do any statistics on percentages. So we never do percentage on 1,0 for 10%. We do the statistics on 0.1 as a proportion of a whole. And so that's cool, but unfortunately what tends to happen is because of the nature of the beast here, the variance tends to be just inherently in a proportional setting, tends to be small at the edges of those ranges. So at the 0 and at the closest to 0 and closest to 1 or unity. And that's not something you guys would do, it's just the nature of proportion. So by applying the arc sine transformation, that tends to make proportional data more likely to be normal. And then the other one is log transform, and that's where we have a lot of like how many gobies do we have in this net, right? So a couple pulls, there's like 1, there's 5, there's 0, there's 3, and then we do a pull and it's like, there's like 300, right? That's a very common thing that we encounter. And so that skewed abundance where we have a lot of none or low encounter or low richness, if we're talking about biodiversity, and then we have a few samples that are very abundant or very diverse. That is not also, those typically also are not normal distributions. So the log transformation is a very, very common tool. And in fact, they're so common, if I have data that's like this, before I even look at the data, I will apply those transformations just out the gate. Okay. And then another common one would be consistent coding. So we ended the class last week. William and a couple people were asking about the categorical descriptors. So how do I deal with, what was it? It was like Georgia and Russia and Ukraine and South Africa, like those kinds of things. And so coding is something that we could do numerically or with letters that just is sort of consistently making sure the data is organized in a certain way. And so some cases, it might be just cleaning up what's in there. In other cases, we might want to make a new code. So maybe we're interested in Brenton's Gobi recruits. And so maybe we want to break up the data into how many, was it babies or was it adults, right? But the data is just in size. So we might say, oh, babies are all guys that are this size. So this size or smaller, I'm going to create a new variable. And if they're at that size or smaller, we're going to say baby. And if they're bigger than that size, we're going to call it adult, right? That would be an example of coding the data. And so another case of, again, nothing's wrong with the data set. We're just putting it in a form that'll be easier for us to analyze or make more sense for the stuff we're trying to do. Any comments about those?
No, those are great examples. I think if, for those of you that might not have taken stats or it's been a while, one of the things that I think when it comes to the transformations that can be confusing is, Dr. A's example is great. I have to deal with it all the time with gobies because I'll pull a net and I'll get one, and then you find that sweet spot and there's like 10,000 of them. But you can also think about it just like something that we're all relate to is just like the average height of people. Okay, so like the average height, everyone here is, we could just say like the average height of everybody's around 5'6" or 5'8", right? That's kind of the average of everyone. If we had, so what do you think the one thing that will like really helps or strongly influence that average height, whether we need to transform it or not? Outliers. So outliers for sure. So if we have like, we have 24 people, 23 people in here, and we have one like 7'2", like Shaquille O'Neal in here, it's going to heavily skew our data, right? So we're going to sit there and we're going to be like, well, it says like the average height of this class is like 6'3", and then everybody in here, other than Dr. A, maybe like, yeah, we're not 6'3", right? And so the transformations can help that. But the other thing, there's one other thing that can really help to try to limit the necessity for transformations. What is that? What do you think that is? So 23 people in here. More samples, right? So if we like, instead of like, we took the average number of like the height of everyone in this classroom, and then we're like, okay, well, let's just do everyone that's in Sierra Hall right now. So now we just like went from 23 students to like 300 students. Now that 7'3" person, it's still real data, right? You don't want to remove it. It's an outlier maybe, but it's still real data. But that's not going to heavily skew our data anymore. So really, a lot of times when you have to do these log transformations or these arcsine or whatever, reciprocal, there's square root transfer, there's all kinds of different transformations. It's usually because you have these big outliers, but they're probably also in a data set where there's few, or the n, the sample size is really small, so that one or two outliers is like strongly influencing that data set. Let's keep that in mind as well.
Cool. A related thing is, so that was data wrangling, and then another thing very related is cleaning, right? And so again, hopefully if this is your data and you've been entering it and you did everything correctly, this shouldn't be that big a deal. But again, anytime we get a data set, we believe it, but we were approaching it with a little bit of skepticism. So let me just make sure that it's all golden. Let me make sure that everything is coded correctly. So cleaning is basically getting rid of errors, right? So accidental, usually, like someone typed like if I was typing 9, but instead had my shift key and I put a parentheses or something of that nature, right? Okay, so that's an error. And I want to get that out, right? So again, we want to have no garbage in, so we have no garbage out. And so there's many things to possibly look at here. But the first one is that numbers are really numbers. And this is a very, very common, I think this is one of the most common errors, or errors is the wrong term, the most common things that gets us tripped up. When we look at our Excel tabular data sheet, it might say, 1, 0, 1, right? We're like, okay, cool. It's 101. It looks like 101 to us, but just because it looks like it to us, that could be recognized as a number, as 101, which is a quantity bigger than 100, smaller than 102, or that could be coded as text. So that could look like 101, but the computer and all the machines that would look at that wouldn't see it as a number, just see it as some random alphanumeric tag. So that's one we want to check. And then another common one with numbers is sometimes accidentally, as we're typing stuff in, we get an extra 0, or an extra, instead of putting a decimal, if we're doing like 91.3, 94.7, we might say 947, something like that. So those are very common ones to see. And then another one are these phantom characters. So one of the biggest challenges that we have is our space bar. So very common, we'll say none or something, right? And so one cell will say none, the next one will say none, the next one will say none. And when and then the next cell also says NONE, but unbeknownst to us, there's a space after the last E. So visually, it looks just like the other values above it and below it. But again, it's not going to be considered as the same thing. It's going to be considered none with a space. And so those are the most common ones that we want to catch as we're cleaning. So this is not this is a data set we'll work with after today. But basically, this is a data set from the recent LA fires and people jacking up rents on folks. And so this is a crowdsourced data thing. This is a Google sheet. This is cool. This is citizen science in action. No one gave anybody the marching orders. This one lady was like, "Oh my God, I think it looks like rentals and houses, they're just skyrocketing." So she just started talking to her friends like, "Yo, have you guys seen anything like this on Zillow or wherever you're looking for apartments?" And so people started crowdsourcing it. So hundreds of people have helped this. which is great. But that also means hundreds of people that aren't intentionally trying to mislead us, but they're just doing their best, right? And so if we come look at this, and what I've done here is I've grabbed all of the different categories and have a look. Go from the top down. What do you see?
Oh, LA's repeated Los Angeles.
Yeah, there's a space in front of the L in Los Angeles. And then, sorry, I should have explained. On the right is the number of instances that's in the data set. So that happened one time. So somebody accidentally put a space in front of the L in Los Angeles, but Excel and all the other software tools will see that as a different thing. They won't see that as Los Angeles. They're going to see that as space Los Angeles, right? And the same thing, if somebody did one for Beverly Hills, they accidentally had a comma and a space. And so even though there is another Beverly Hills farther down, you can see there's 27 instances of people finding increased rent there. But in that second line, that's not going to be in that data set. Then if we go farther down, let's look at Los Angeles. Look at that. There's 182 Los Angeleses, but then there's also 8 Los Angeleses. So it turns out that 8 is a case where someone had an accidental extra space after the last S.
There's 3 LAs.
Oh yeah, and there's just capital L period, capital A period, right? So again, this is a perfect case of data cleaning. So okay, I got my data. I'm going to go in and I'm going to find all those cases of space Los Angeles and turn them into just Los Angeles, and all those places of L, capital A, and turn them into Los Angeles. Everybody got me? So that's basically data cleaning. Okay, cool. And then after all that, then we can get to our first real figure, right? So again, it's not that we don't want you guys to get into graphing soon, but we want to make sure we're going through all of this proper prep before we get there. Okay, so cool. So let's try it. So let's take a look.